All right, so now we'll take a look at what happens if we want to find the area to the right. So we have here the normal distribution, actually the standard normal distribution probability density function. And if we were going to use the CDF, which is the phi of z, the phi of z would actually give us this area over here to the left of that z-score. So phi of z is this area over here to the left of the z-score. What we're being asked for is actually the area to the right. So we don't want phi of z. We want the complement of phi of z, and that's over here. So since we want the complement, to find the complement, we do 1 minus the probability. The probability to the left is phi of z. This is 1 minus phi of z. So we're going to do that in Python by using scipy.stats, and we're just going to do exactly what it says down there. 1 minus, remember, this is Python's version of phi of z. You just call this method and you plug in z, whatever the value is here, this quantile value. All right, so let's go try. Actually, there's one more I want to look at. Let's take a look at the area in between also. So not just the area to the right, but what if you wanted to find the area in between? Well, for the area in between, since we have two z-scores here, z2 and z1, z2 being the larger of the two, the phi of z2, the larger one, is the area from z2 all the way back, all the way to the left, while the phi of z1 is the area from z1 all the way back. So if this is the area to the left of z2, right here, and this is the area to the left of z1, if I subtract those two, I'll get the area in between. And that's exactly what I'm doing in Python. I'm just taking that phi of z2 and subtracting the phi of z1. All right, so here we go. So when you see a problem like this, it says sketch the region. Well, when I see 1 minus phi of 0.2, well, that means that the z-score I'm looking for is 0.2. That's the quantile value, 0.2. But I'm not looking for the area to the left since it's 1 minus that area. This is actually the complement. I'm looking for the area to the right of the value. So that's what they're asking for there. That's a quick sketch. Oh, well, this one is sketch the region corresponding to this statement. Well, this is the difference between two CDF values, the difference between two areas. So it's the area in between those two. So I look for the area in between here, between two values, and I go for 0.3 as the larger value. So 0.3 is up here, and negative 0.9 is the smaller value, which is back here. And that's what it's looking for. So this symbol represents the area in between those two. It's the difference of the two CDFs. All right, let's see. So next one. Okay, so as you can see, question 5 here, we have a normal distribution, standard normal, because it's a normal, but the mean is 0 and the variance is 1. And then it says find the probability, and the probability it's looking for is 1 minus the CDF, the standard normal CDF, evaluated at 0.87. Now, that's the area to the right of 0.87. There's 0.87 on the x-axis, or the z value of 0.87, and we're looking at the area to the right. So I'm going to use Python to find that area. I've already used Python to find an area to the left earlier. So I'm just going to add a code cell, and since I've already imported scipy.stats, I'm not going to have to import it again. If you haven't imported scipy.stats, the first thing you have to do is type out import scipy.stats as stats. The next thing then is we're going to actually find the CDF value. I'm going to copy this much of the code, and then I'm going to do 1 minus is what I need, because this is 1 minus that CDF. Then I'm just going to paste in the CDF for 0.87. So close that parenthesis, and when I run this cell, it's going to give me the area to the right. So that area to the right of 0.87 is 0.1922 when rounded to 4 decimal places. That's 0.1922. All right. And then here again, we have the difference in two CDFs. So since it's the difference in the two of them, it's the area in between those two Z values there. So the Z value of 0.97, the Z value of negative 0.53. I'm looking for the area in between. And I'm just going to subtract those two CDFs then. So I'm going to add a code cell here. And let me just take this part of it here with the subtraction. And we will not need to import SciPy once again. It's already been imported. And I actually want another one of these. So I'm going to subtract two from each other. Let me get rid of that subtraction in the beginning. So I'm subtracting these two CDFs. The first one I'm subtracting is for the larger of the two, 0.97, close parenthesis. So that's the first one. That's the CDF of 0.97. Then I'm subtracting from that the CDF of the smaller of the two, negative 0.53. So that's negative 0.53. And I close the parenthesis there, and I go ahead and run that, and this would be the area between negative 0.53 and 0.7. I said it backwards, but this would be the area that I put in here to 4 decimals. That's 0.5359. So that's 0.5359, and that's how we find the area in between.